Okay, now that we've looked at the inner planets, we're going to go beyond Mars here and look at the outer planets. These are typically gas giants, at least the first couple are. Again, typically the outer planets are much larger than the inner planets. The term gas giants refers to the fact that many of these planets are made primarily of gas. That's the gas part. Giants, much larger than Earth. Jupiter is pretty much the king of these. It is the largest planet in our solar system. It is the fifth planet from the sun. It has a diameter roughly that of 11 times that of Earth, so 11 Earths could fit in it. Its orbit is around 4,331 Earth days, which gives it approximately 12 Earth years as it goes around the sun. It has the fastest rotation speed of any of the planets of the solar system, only 9 hours and 56 minutes, so just shy of 10 minutes. One of its most prominent features is the Great Red Spot, seen in the picture here in the lower right hand of Jupiter. One of the things about Jupiter that has made it somewhat fascinating is the large number of satellites that Jupiter does have. Jupiter, let's see where to go. In 1979, the Voyager 1 spacecraft located several rings around Jupiter, which were so faint we hadn't detected them yet. The largest ring is about 4,000 miles wide, only 20 miles thick. In 1610, Galileo saw the four largest moons of Jupiter, hence the reason they are called the Galilean satellites: Ganymede, Callisto, Io, and Europa. If you watch a lot of sci-fi, some of these names might pop up from time to time. They're called the Galilean satellites. Galileo's discovery of Jupiter's four largest moons, many small moons have been found, or since that discovery, many small moons have been found orbiting Jupiter. Over 60 moons are now known. More are being discovered. It is such a large planet that it does not, it's not that hard to believe that there's so many moons orbiting it, and that we're still actually discovering some of them. Let's see. Ganymede is the largest moon in the solar system that we know of. Kind of hard to believe that we might find any that are larger than it, considering that we probably would have found them by now if they were. So that one is the largest. Io is the most volcanically active in the entire solar system. Io has an unusually shaped elliptical orbit due to the poles of Ganymede and Europa. The cracked surface of Europa is made almost entirely of water ice. Astronomers believe that there might be liquid water or water ocean underneath that ice. We really don't know yet because Jupiter is so far away, it's kind of hard to observe things there. So, some of these things about planets, we're still discovering. We're still learning about them. It was only just recently that we discovered that there was ice on Mars, in the dirt part of Mars, not at the caps. So, we're still learning about these planets out there. It's not that everything is known about them yet. Especially these gas giants, the further away from the Earth we go, the less we know about them. But these gas giants are so big, and their atmosphere is filled with so much different gases, we really don't know what's inside. It's hypothesized what's inside, but again, sensors and stuff have not been able to delve very deep in many cases, partially because of the distances involved. Saturn is the sixth planet from the sun. It is also the second largest planet. It's known for its rings. Someone once said God must have liked it because he put a ring on it. Its orbit is around 10,747 Earth days, roughly 29 and a half years. Its rotation is only a little bit slower than that of Jupiter at 10 hours and 39 minutes. Within the rings, it has some prominent things there. And it was once thought that Saturn really only had one ring. And that was due to limitations on technology, really, at the time. And as we've discovered more, as we've improved technology, we realize that there is this large gap between rings A and B. You can actually see it in the picture there. This is called the Cassini division. And this gap is about 3,000 miles wide. Most of the rings have been named with letters, such as A and B, hence the reason why we say the large gap between rings A and B. Within the rings, there are shepherd moons. These travel within the rings and apparently keep the rings in place. The gravity and motion of these moons keeps the dust and ice and such within the rings there. The moon Atlas helps regulate the outer edge of ring A. Two of Saturn moons also keep the gaps open. So where we see these spaces in the rings are apparently due to the movement of moons around Saturn. Titan is Saturn's largest satellite. It is the second largest satellite in the solar system, and it's the only moon in the solar system that has a thick atmosphere. One of the things that is typical of moons is thin atmosphere or no atmosphere, but Titan's is thicker than most. That's also one reason why in science fiction, Titan tends to end up being populated in science fiction because of the fact that it does have this thicker atmosphere to it. Let's see. Yeah, some other of Saturn's moons. Enceladus has a surface of water ice. Also may have an underground ocean. Near its south pole are 4 fissures nicknamed the Tiger Stripes. Geysers in there shoot cold water vapor over 120 miles above the moon's surface. Then there's also the moon Iapetus. And half of the moon is as dark as coal, while the other half appears quite bright, most likely due to mineral contents on the surface there. The moon Mimas, or Mamas, the closest major moon to Saturn, has a crater with a diameter 1/3 the diameter of the moon. And then Phoebe is Saturn's outermost major moon and orbits Saturn in the direction opposite most of the planet's other moons. Once again, we have kind of a variation here on a theme where the moon is traveling in what seems to be the wrong direction, going the opposite of all the other moons. And that's Phoebe around Saturn. Next, we have the planet Uranus. It is the 7th planet from the Sun. It was the first new planet discovered in 1781. Its orbit is 30,589 Earth days, roughly about 84 Earth years. Very few humans alive on Earth today consider they've been around for one entire orbit of Uranus. Its rotation is only 17 hours and 14 minutes. It does have retrograde rotations, meaning that it goes the opposite of many of the other planets. For us, the sun rises in the east and sets in the west. On Uranus, it would rise in the west, set in the east. It is a gas giant. It also has a 98-degree tilt to its axis. It's practically on its side. And this is actually one of those things. It's retrograde motion and it's tilted on its side that really causes some problems for many cosmologists as they try and describe the beginnings of the universe. Because every planet should have started out uniformly, all the gas swirling around, dust and particles swirling around, slowly coalescing into the middle, forming the sun, and then as it continued swirling, forming the planets. So all of the inertia for all the planets would have been in the same direction. And here we have a planet that is retrograde, one of two that we've talked about so far. So it's spinning backwards, and then its axis is completely on its side, much stronger of a tilt than any other planet in the solar system. Earth's tilt is only around 21 degrees. Many of the other planets don't even have a tilt. And then this one is practically lying on its side. Uranus was discovered by William Herschel. He was charting the stars near the constellation Gemini when a relatively bright star-like object attracted his attention. After further investigation, astronomers realized the object was neither a star nor a comet, which some had proposed. Herschel discovered Uranus just through careful observation. He was looking at the Gemini and went, wait, there's something new here, and looked at it. Uranus also has around 27 satellites. Let's see. Uranus, it is composed of hydrogen and helium. In 1977, astronomers discovered that Uranus has its own ring system. So we're starting to see a theme. As we've studied these planets more, we found more and more of them have rings. None of them quite as bright or as brilliant as the rings of Saturn, but they're rings nonetheless. Uranus has at least 27 satellites. Like the rings, these moons orbit near the plane of the equator. William Herschel discovered the first two moons, Titania and Oberon, taken from William Shakespeare's play A Midsummer Night's Dream. The moon Miranda has a canyon that is 12 times deeper than the Earth's Grand Canyon. Cordelia and Ophelia are shepherd's moons, guiding the rings around Uranus and rotating along its orbit there, orbiting around its equator. That's what I meant to say. So that's Uranus, the seventh planet. And then the last planet, Neptune. It is the eighth planet from the Sun. It was the only planet discovered mathematically before it was seen. What happened was astronomers were observing slight irregularities in the orbit of Uranus, nothing that they could actually account for with what we knew about. They thought it might be caused by the gravitational pull of an undiscovered planet. Mathematicians John Couch Adams and Urbain Jean-Joseph Leverrier separately computed the position and size of a planet that could produce such irregularities. Because we know a lot about gravity, we have equations about gravity, it didn't take them very long to actually calculate it out and figure out some of the details about what they'd be looking for in this unknown planet. In 1846, Johann Gaula of the Berlin Observatory turned his telescope to the predicted position and saw the new planet for the very first time. So Neptune was actually calculated to exist before we had ever made any observational discovery of it. Since then, we've learned that its orbit is near 164 Earth years. Its rotation is only 16 hours and 7 minutes. It has 13 satellites so far discovered. And Triton is the largest of Neptune's satellite. One of the interesting things, we looked at Uranus and Neptune. They both have this blue color. They're actually both made of the same chemicals. And we really don't know why one has a different blue than the other one. Most likely it's from additional chemicals or other features on the planet that have yet to be discovered as to how it actually goes along with the color scheme there. Now, I said that Neptune was our last planet. You may have heard that Pluto is the ninth planet from the Sun. Well, that is both true and not true. As I was growing up, it was Pluto was the last planet. I was taught this way of remembering it. My very elderly mother just sat upon 9 pins: Mercury, Venus, Earth, Mars, Jupiter, Uranus, Neptune, Pluto. Well, some people got together and they actually gave a definition for planet. Remember, the old Greek definition just meant wanderer, and that was not specific enough. And so it kind of only had the definition here up until recently as defined as an object that orbits the sun. That was pretty much it. So some scientists got together, astronomers in 2006, to resolve some of the conflicting data they were getting because they found Pluto. Pluto is a small rock of a planet. Pluto's tiniest diameter is only 2/3 the size of the Earth. In 1978, astronomers realized that Pluto has a moon that is almost half its size. Is it a moon or is it something, a different way of calling it? They called the moon Charon. 2 more moons were discovered in 2005, Hydra and Nix. They're much smaller than Charon. In the late 20th century, astronomers began discovering many other trans-Neptunian bodies near Pluto. Eris was one of these objects, and it's larger than Pluto, although still smaller than Earth's moon. Astronomers disagreed about whether the largest of these objects should be called a planet. So in 2006, they got together, tried to define what a planet is. Now, they came up with this definition. It is an object that orbits the sun, has enough gravity to be a sphere, and has removed small objects from its orbit. Unfortunately, the definition's second and third descriptions are based on evolutionary ideas and not so much on observation. The first one, it could be easily observed. Does it orbit the sun? Yes or no? Okay, yes, it does. The second one is kind of half and half, actually. Is it a sphere? Now, the way that they phrased it, it has enough gravity to be a sphere. That's assuming that the shape is a result of gravity. And we really don't know if that is the case, to be honest. But we can look at the planets and say, okay, is it a sphere? Like I said, it's kind of half and half. We can see if it's a sphere, but we don't really know if it's caused by gravity or something, or if there are other factors that are involved in that. So, I mean, that's one we can check on. The third one, again, kind of half and half. Has removed small objects from its orbit. Well, how do we define that? We don't know if there were any objects in its orbit to begin with. So, does the fact that there's no objects there now fit that description, or is it more about it needs to hurtle other things away from it or absorb it in the form of moons and such? We don't know how any of this formed, so to say that it cleared its path uh, of all these small objects, and again, that's going heavily on what they believe to have happened in the past without without any type of evidence, really. Because when we look at meteoroids later and stuff, we'll find out that some of the belts are in the path of planets. They're within the orbit of the planets. Does that count as clearing its path or not? So there is actually still discussion about whether or not Pluto should be a planet. There will probably be discussion for a long time until they actually come to a definition that makes sense for all parties. Pluto and other objects like Pluto are referred to as dwarf planets. According to this definition, Pluto, Eris, and several other similar objects are dwarf planets. They orbit the sun. They have enough gravity to be a sphere, but they do not remove smaller objects from around its orbit. Some astronomers still question whether the presence of these objects should have removed Pluto from the list. So there is still discussion about that definition to this day. Astronomers now use the name Plutoid to refer to any trans-Neptunian dwarf planet. Plutoids include Pluto, Eris, and many other dwarf planets that are found in that same region. So these are the outer planets, and we will see you next time when we get into some other heavenly bodies that roam around our solar system.